Let us try to identify some electronic components. This one is a LED light emitting diode. It comes under semiconductor chapter. As you can see, one leg of the LED is longer than the other one. This is done to indicate the positive and the negative terminal. Similarly, I have a very commonly used LED. Here also, as you can see, one leg is longer than the other one. Again, this helps in identifying which is the positive and the negative terminal. This is a diode which has again two terminals, but on the diode you can see that there will be a silver line indicating the polarity of the diode. Silver line indicates negative side of the diode. It has two ends, but both the ends of the diode are in a straight line, unlike your LED. This is also a diode, but this does not emit any light. Again, a diode can be connected in a forward bias only. So that's why the polarity is very important when you connect any diode. A similar diode having a different configuration and different in size. These diodes, which are in black in color and silver lining, can be connected only in forward bias and not in reverse bias. There is a special type diode called as the Zener diode, which can be connected in reverse bias. A Zener diode looks somewhat like this, which has a black line again indicating the negative terminal. Well, you know this one. This is color coded two terminal device. This is the resistance. It's a small resistance in fact. By knowing the color code values, you can easily find out the value of this resistance. Here we have a LDR, light dependent resistance. It has again two terminals, no polarities. The only difference is the resistance of this value changes according to the light that is falling on this material. As the light falls on this, the resistance value of this component keeps changing. Hence it is called the light dependent resistance. And of course, you know this resistant box. We have also seen the working of this resistant box in our previous videos. This is used in the labs for experimental purpose only. Here we have a ceramic capacitor. Ceramic capacitors do not have any polarities, hence the two ends of ceramic capacitors are of same length. Here is another example of ceramic capacitor. If you notice, capacitors are not written with the values directly sometimes because of the sizes. In that case, the number written can be found out online and looked out for the configuration. There is always a number printed on such small components, which helps you to identify the configuration of such electronic components. So these are the three types of ceramic capacitors which I could find having different capacitance. If you ever go to a shop and ask for capacitors, they will always ask you the type of capacitor and the capacitance that you need. Such capacitors are called electrolytic capacitors, which have polarities. You will find such capacitors used in fans. Again, the long end of the capacitor is the positive terminal and the short end is the negative terminal. Let us try to see what's written on this. It's written 63 volt 100 microfarads 85 degree Celsius. That is the range up to which you can use it. And if you see, the long end is a positive and the short end is negative, and it will be always marked like this. There is always a marking done to show the negative terminal, and the positive terminal is always long, and such information is always written on such electronic capacitors. The electrolytic capacitors are larger in size, hence it is possible to write down the details. Let me pull up another capacitance and show. Here it is 16 volts 470 microfarads, and again it's written negative terminal X Y X G. I don't know what is it. And again you are given the temperature of 105 degrees. That is the maximum temperature up to which it can operate. And there is a number given, which if you type it online, you will get more information about this capacitor. Here I have another capacitor. (10 microfarads) to 50 volt. That is the operating voltage. Minus 40 degrees to 105 degrees, so that is the range. And again the short end. So here as you can see, the long end is the negative terminal. So probably what has happened is, this was removed from an circuit, so while removing, the long end is become the short end. So that is the reason why the marking also helps. This is a transistor. A transistor has 3 legs. A transistor is a combination of P and N type of semiconductors in different combination. To identify a transistor is that you will see 3 legs. This is a small transistor, and on this transistor, if I twist it, you will see some numbers written. If you type in this number BC547B, you will get the full electronic configuration of this transistor, talking about the operating voltage, talking about the temperature range, the terminals, which terminal is the emitter, base and the collector. So you don't have to actually memorize or try to remember all the transistor details. If you look from top, the shape looks something like this. So this shape will be also drawn on the PDF file, which you can get easily online, free of cost, and that way you can identify which terminal is emitter, base or collector. Here we have another type of transistor, again 3 legs, and again you can see some printing is done on this that will help you identify what is the electronic configuration. D13005D. If you type in this number, you will get it, and you can see a small dot on the extreme right leg that will indicate the terminal, whether this terminal is emitter or base. The back of it is just blank. This is another transistor, again having 3 legs. It has 3 legs. the print of this transistor is not visible anymore, but when you buy a new one, you will get a print written, some numbers will be written on this, again for you to easily find out what transistor is this. You can see a small hook over here, small outing which is come out, metal piece, that will indicate whether this leg over here, this leg is the closest to that small notch what you see, whether this leg is emitter or base. So any 3-leg components will be a transistor. When you connect all these components in any circuit, then we get a bigger circuit which may look somewhat like this. Here you have different components. Let us look at that. The first one here is your resistance, again color coded. You have diodes, again you have diodes over here, capacitance, again capacitance, again capacitance. You have another small diode over here, it's a Zener diode. Again here also you have a diode. This one will become your 3 terminals transistor. Again you have capacitance, capacitance, capacitance. You have a coil here, it's acting like a mutual inductance. Here you have a small transformer. Again there is primary and secondary coils over here, and back over here again you have your capacitance. So this is quite a huge circuit. It's approximately around 5 inches long. But imagine you make this whole circuit into a small tiny thing. What if you can compress this? How will it look like? Well, I would not say literally you compress the same circuit, but when you try to minimize everything into a small circuit, that will be looking something like this, which is called as your integrated circuit. So here we have an IC. Many times we hear this in movies, an IC chip we say. This is basically an IC, integrated circuit. Inside this we have something called as the gates, which give you the desired output. Again, these come with different numbers. Each number, again if you Google it, you can find out what are the electronic configuration of this IC. You can see a small cut over here and a small dot over here that indicates which side is the front side, and the small depression over here, what you can see, is indicating which is number 1. So these terminals are numbered basically, and each number indicates either an input, an output, input voltage, a ground. All this information is available. On this top over here, the number is given of this IC, which you may not be able to see right now, but I will put this under a magnifying glass and show it to you. Such ICs can be of different number of legs, can be of 4 legs, this is of 8, you can have 16 legs, and to make it easy to replace them, you get such kind of a base for ICs, such that in a circuit you can have this base and then you put your IC onto this. So it becomes very easy to fix it. So anytime someone says your IC is gone, or you find out the IC is gone, then you can easily replace the IC without damaging your circuit.